Alright, let's continue. We'll be finishing everything that's in exercises 1.6 of Mr. John Coburn's Precalculus textbook. So, for number 78, the previous video, we stopped in number 77. Now we'll be starting in number 78. We'll finish it all the way to number 85. Another thing that you're supposed to know is that, why am I saying exercises 1.6? There are many variations of the Precalculus textbook that is authored by Mr. John Coburn. In the Philippine edition, it's considered 1.6. However, in the American edition, it's actually 5.6 if I'm not mistaken, or 4. I'm likely sure it's 5. But anyways, let's continue. Observing wildlife. So from her elevated observation, let's draw an observation tower here. Just imagine that this rectangle represents the elevated observation, and this is the girl. So 300 feet away from which object? A tree. So let's just say that this is a tree, and this is the baboon that they are referring to. Oops. Sorry about that. There you go. So using a small transit attached to her telescope, she finds an angle of depression to the bottom of the tree, which is 14 degrees. So angle of depression, 14 degrees. What remains in this portion? 90 minus 14 degrees would be equal to what value? We get 76 degrees. Right. Sorry. Just have to adjust quite a bit. Okay. While the angle of elevation to the top of the tree is 25 degrees. The very top of the tree is located here. So this is 25 degrees. And angle of elevation to the troop of baboons to the top of this particular baboon is 21 degrees. So, based on this information, by the way, the line of orientation, which is here, is also equal to this distance over here, which is 300 feet. Right. Let's proceed to solving for what's being tasked to find in letter A. What is the height of the observation post? So this is obviously what's missing. Earlier, this is what I drew that would represent the elevated observation post. So given we have 76 degrees and an opposite angle, based on this angle's perspective, what we're looking for is the adjacent side. So we use TOA. Tangent 76 degrees is equal to 300 feet over the adjacent. So let's just say this is the adjacent. Right. Put adjacent here, and 300 feet over tangent of 76 degrees. I hope you have your scientific calculators with you. I'm already expecting you to have already set it in degrees, since in these problems actually, I'm sorry, I lost some concentration. Anyways, you have to set your calculator in degrees. Otherwise, you might get a different answer. So for adjacent, it's 74.79, rounded off, let's say 74.8. 74.8 feet. That's the height of the observation post. Right. Apologies for that sound. Let's move on to letter B. What is the height of the baboon's tree? So this is what we're looking for. In order to solve for that, I think it's pretty obvious that you've already known the height of the observation post. It's basically this one. But what we're looking for this time is this. So how do we find it? We'll still use the same TOA. I'll redraw the triangle here. We'll be using the triangle that has 25 degrees, and this is the missing value, and this is the 300 feet. So tan 25 degrees is equal to the opposite side, the missing value. We have to divide it with 300 feet, which presents itself as the adjacent side. So opposite is equal to 300 tangent 25, which is equal to 139.89 feet. So given this value, this is 139.89, and the adjacent side would present itself as 74.8. I think it's pretty apparent that you just have to find the sum of those two values. So 139.89 plus 74.8, we get a value of 214.69 feet. That is the height of the baboon's tree. Okay, for letter C, we have to find the height of the baboons above ground. So this might be quite confusing, but essentially, basically asks the height from the top of the baboons all the way to the bottom. So in other words, we just have to add the adjacent side value, which is this one, the 74.8 feet, together with the value that we'll be finding at a 21-degree right triangle. So let's just try to assume that this is opposite, say Z. So opposite Z. If you, just in case you're wondering where the heck did I get the letter Z, it's actually I'm not sure if it's accepted, but then I tend to become creative in terms of this. We don't want to make things confusing, but then at the same time, we want to be to familiarize ourselves with what we're actually looking for. So just pretend, just assume that this is opposite sub Z. So what you have to deal right now is, how are you supposed to find opposites of Z? Of course, we still use TOA, since if we draw the triangle again, it's going to look like this. And this is opposite sub Z. This the distance over there. So tangent 21 degrees is equal to the opposite side over 300 feet. Basically 74.8 feet, which presents itself as the adjacent. You add it with the 300 feet tangent 21 degrees. So 74.8 plus 300 tangent 21, we get 189.96 feet. That is the answer for letter C. I'll be back in a few seconds. I'll be back in a few seconds, I'm sorry. Pardon me. Things aren't as always. Things don't go as planned always. So, yeah. We've already found the height of the baboons above ground, which is basically 189.96 feet. So, yeah, I think we've finished number 78. Oh, damn. It's quite complicated, but then if you could understand this, then it's going to be easier for you to answer other word problems that share the same strategies in terms of how you're supposed to solve them. So for number 79, angle of elevation. The tallest freestanding tower in the world is the CNN Tower in Toronto, Canada. The tower includes a rotating restaurant high above the ground. So I'm starting to realize I've actually never been to Canada, but then I'm starting to realize that this is the restaurant. And from a distance of 500 feet, the angle of elevation. Alright, let's try to visualize. Actually, no. The illustration is already here. You just have to figure out which are we supposed to solve for. So, from a distance of 500 feet, so this is obviously what's being referred to in this specific phrase. The angle of elevation to the pinnacle of the tower is 74.6. So this is the pinnacle, I suppose. And the angle of elevation to the restaurant from the same vantage point. I'm assuming that I'm starting to realize that this is the vantage point that's being referred to. And 66.5 degrees. Yeah. From the same vantage point, angle of elevation to the restaurant is 66.5 degrees. The first question is that it asks about the height of the tower. I've already labeled specific letters here. In other words, we're supposed to to find the value of AC. So let me redraw the triangle. Here we have 500 feet, and this angle goes all the way to the pinnacle, so this is 74.6 degrees, and this is what we're missing. So given a missing opposite side and a given adjacent side, we use TOA. Tangent 74.6 degrees is equal to the opposite side over the adjacent, which is 500 feet. Opposite side is equal to 500 tangent 74.6 degrees. So I hope you have your scientific calculators with you. Even at this beginning of this video, you should have your calculators if you want to practice along with me. So 500 tangent 74.6 is 1815.24 feet. This is the height of the Toronto CNN Tower. Right. The second question. We have to find the length. How far below the pinnacle of the tower is the restaurant located? So the length between the pinnacle to the restaurant is missing. In other words, what we're looking for is BC, the line BC, this one. So how are we going to find BC? This is actually basic logic. BC is equivalent to AC minus AD. So I hope you could understand that specific logic. It's going to be useful if you know it, especially when solving these problems. It's not so difficult once you realize the mechanisms. So for BC, actually no. This opposite right here is AC, right? So this value is already given. We have to solve for AB. So in that sense, we have a triangle here with an angle of elevation of 66.5 degrees. The same length at the bottom, which is 500 feet. And this measurement here is missing. This is a B, correct? So what we want to do now is still use TOA. So tangent 66.5 degrees is equal to opposite side, which is AB, divided by 500 feet. So AB is equal to 500 tangent 66.5, which is equal to 1149.92. So we'll use that value. I suppose we could now subtract. So BC is equal to 1815.24 minus 1149.92. Okay, so BC then is equal to 665.32 feet. So yeah, that's it. Let's proceed to number 80. Angle of elevation. I suppose this is the same concept. Like the previous problems, particularly at the crop duster problem that I solved in the previous video, as well as the train speed word problem. There are many ways to illustrate the situation in problem 80. So, but this is one of them. In August 2004, Taipei 101 captured the record as the world's tallest building. So I'm starting to realize that Taipei 101 is a building. I'm not really familiar with these things outside of mathematics, but yeah. The sentences already, the first sentence already implies that Taipei 101 is a building. So measured at a point of 108 meters from its base. Okay, let's say this is a distance. This is the 108 meters from its base. And the angle of elevation to the top of the spire. So I'm starting to realize that, let's say this is the spire of the building. I think spire, from what I know, and what my classmates also know, spire is also, in other words, also known as pinnacle. Usually, the top parts of the building, if this is the roof, this is the pinnacle or the spire. So the angle of elevation to the top of the spire is 78 degrees. and from a distance of about 95 meters, say this is 95, the angle of elevation to the top of the roof is also 78. So I hope you could notice this part, um, top of the spire and top of the roof. This is the top of the spire, and this is the top of the roof of the building Taipei 101. And the angle of elevation is also 78. Coincidence? I don't think so. Probably not. Anyways, the first question is, how tall is Taipei 101 from the street level to the top of the spire? So all the way from street level to the top of the spire. This is what we're looking for in the first question. So obviously we're going to use this triangle. It's basically TOA. Tangent 78 degrees is equal to opposite side. Say this is opposite 1. Divided by adjacent, which is 108 meters. Opposite 1 is equal to 108 tangent 78 degrees. Opposite 1 is equal to what? 108 tangent 78 is equal to 508.1 meters. This is the actual height of Taipei 101, including the height of the spire. So for the second question, how tall is the spire itself? So this is what we're looking for in the second question. In order to find that, of course, we use our logic, our common sense. From this value, we subtract the height of this one. The height of Taipei 101 from the street level to the top of the roof only. If you subtract those two values, we get the height of the spire itself. So let's say this is opposite 2, and what we're looking for in the second question is the opposite 3. So opposite 1 minus opposite 2 is equal to opposite 3. There you go. We have to solve for opposite 2, of course. We already know the value of opposite 1, which is the answer in the first question. You just have to find opposite 2. And afterwards, we subtract. So, TOA, tangent 78 degrees is equal to opposite side over adjacent, which is 95 meters. Opposite side is equal to 95 tangent 78 degrees. So from that, opposite 2 is equal to 446.94 meters. So opposite 1 minus opposite 2, in other words, 508.1 meters minus 446.94 meters is equal to what? 61.16 meters. This is the height of the spire itself, the spire alone. There you go. Alright, let's move on to number 81. I'm sorry. This is actually number 83 and 84. 85. I wonder where 81 and 82 went. Why are they not here? So sorry. Apologize for the inconvenience. I'll be dealing with numbers 81 and 82 in the next video. For now, we'll be finishing 83 to 85. So, for number 83, the word problem is all about contour maps. Hang on. I'm sorry. I believe we won't need to make a new video, another video on 81 and 82. I'll just write the questions by hand. So for number 81, we have to find the impedance Z if the phase angle, which is defined as theta, is equal to 34, and resistance, which is labeled as R, is equal to 320 ohms. Right. You just have to know that in alternating current, this is actually one application of right triangle word problems. This is what these problems are called, alternating current, or in short, AC. It's probably familiar. I hope so. We do have to acknowledge that we have three values in AC applications. Z stands for impedance. The unit for impedance is ohms. And for R, it's called resistance, which is also of the unit ohms. And the theta is the phase angle. Whether it's an angle of elevation or depression, but usually it's usually elevation. It's labeled, of course, in degrees. So you just have to know these, and yeah, I think you're good to go. Okay. You do have to note though that the hypotenuse will always be the impedance, and resistance will always be the adjacent. And the phase angle, of course, would be this one. So specifically in this problem, the phase angle is said to be 34 degrees, and the resistance is 320 ohms. Impedance is missing. So given adjacent and hypotenuse, we get cosine. So cosine 34 degrees is equal to adjacent, which is 320 ohms, divided by hypotenuse, which is Z. Z is equal to 320 ohms divided by cosine of 34 degrees. So put those values in the calculator, and we get 385.99 ohms. This is the final answer. Yeah, there are new terms that correspond to the general parts of a right triangle in the context of precalculus. But then, yeah, the system of solving stays the same. It may look difficult at first, but then if you tried answering them, then you'll realize that it was really easy after all. So let's move to number 82. Find the phase angle. So this time the phase angle is missing. Again, it's labeled by theta if the impedance, which is Z, is equal to 420 ohms, and the resistance R is equal to 290 ohms. So given those values, let's draw the triangle again. Hypotenuse, as stated earlier, will always be the impedance, and the resistance will always be the adjacent. Phase angle is missing, And then for the impedance, it's 420 ohms, and the resistance is 290 ohms. We still use the same as earlier, Ka from SOHCAHTOA, but this time what we're looking for is the theta. So just label them as usual, adjacent over hypotenuse. We press shift in the calculator, so angle of theta, which is the phase angle, the missing value, is equal to arc cosine, if I'm not mistaken. That's how you call it in English. Arc cosine 290 over 420. Write this in the calculator. In order to write arc cosine, just press shift and cos. So we get something, actually a specific value of 46.33 degrees. This is the final answer for number 82. Okay, let's move on to number 83 now. Contour maps. In the figure shown, the contour interval is 175 meters, such that each concentric line represents an increase of 175 meters in elevation. So basically, if you're wondering what concentric line means, it's the number of lines that you have here in this illustration. So 1, 2, 3, 4, 5. You have 5 lines in terms of vertical change. Anyways, I wouldn't want to confuse you immediately. Let me try not to confuse you. The scale of horizontal distances is that 1 centimeter is equal to 500 meters. So earlier, the contour interval, I suppose that this would refer to the vertical change, or VC, and this proportion will refer to the horizontal change. So letter A, find the vertical change from A to B, or the increase in elevation. So for the vertical change, as stated earlier, the contour interval is 175 meters. But then in the graph, in the illustration, we have 5 of them, 5 intervals. So obviously 5 times 175 is 875 meters. This is the vertical change from A to B. If you make this illustration 3D, it would look something like this. So 1, 2, 3, 4, 5. 5 intervals. That's what the mountain would look like. Anyways, for the horizontal change, we have to find the horizontal change between A and B if the measured distance on the map is 2.4 centimeters. So we make use of this proportion that we noted earlier. So if 1 centimeter is to 500 meters, then 2.4 centimeters is equal to how many meters? So that's what we're looking for. The horizontal change is this value. How do we solve it? Basically, 500 times 2.4. That's it. 500 times 2.4 is 1,200 meters. This is the final answer. Pretty basic, eh? Let's finish letter C. So we're supposed to draw a right triangle that's going to be used to estimate the trail up the mountain side connecting A and B. So based on these values, this is the horizontal change, this is the vertical change, and this is the horizontal change. Let's make a triangle right here. There we go. 875 meters would be the vertical, which is this one. And over here, it would be the 1,200 meters. You also have to know that obviously this is 90 degrees, and we want to find this angle as well as the value of the hypotenuse. Those are the two. After forming the right triangle representing the vertical and horizontal change, we want to find this angle and the hypotenuse. In terms of angle, why not this one? Not exactly sure, but then just know that the angle that you're supposed to find is to be directed with TOA, such that this is the vertical change that will be the opposite side, and the horizontal change, which would be the adjacent side. I hope that makes sense. Right. So TOA tangent theta is equal to opposite, which is 875 meters, divided by 1200 meters. Angle of theta is equal to arctangent of 875 over 1200. Theta is equal to, just write those values in the calculator. 875 over 1200 is equal to 36.09, or just 36.1 meters. Okay, now that we've found the angle, you can already find this angle also, but I'm choosing not to do it now. I don't think it's necessary. Still, it's up to you. If you want to find it, please, you have the liberty. Anyways, for hypotenuse, you could solve this using SOHCAHTOA, or there's another way, Pythagorean Theorem. Use the Pythagorean Theorem formula. Hypotenuse is missing. Let's say this is A, this is B. So 1200 raised to 2 plus 875 raised to 2. So put those values in the calculator. I'm sorry. It's better if you square root these already. We get 1485.13 meters. That's our answer for the hypotenuse. Right. We're finished with number 83. Solution's pretty lengthy, but it's pretty easy, actually. It's a subjective claim, but then, I don't know. What do you think? Send some thoughts in the comments below. Let's go for number 84. Contour maps. In the figure shown, the contour interval is 150 meters. The same note, each concentric line represents an increase of 150 meters in elevation. So 1, 2, 3, 4. We have 4 intervals. One contour interval is 150 meters. Scale of horizontal distances, 1 centimeter is equal to 250 meters. Okay, find the vertical change from A to B. Let's recount again. 1, 2, 3, 4. Yeah, we got 4 intervals. So 4 times 150, 15, 30, 45, 60, 600 meters. That's the horizontal change, I believe. Hang on, I need a few seconds. Alright. Sorry for keeping you waiting. I realized I might have made a mistake in the scratch paper, the actual one. But yeah, don't follow my mistake. What I initially put is 4 times 250 for the vertical change. It's supposed to be 150, and because of that, uh, my letter C is entirely wrong. Since given two values, if you compute for the hypotenuse, wherein your vertical change is wrong, then of course the hypotenuse would also be wrong. Might as well the this angle for number 84. Anyways, for letter B, we use the proportion to find the horizontal change between A and B if the measured distance on the map is 4.5 centimeters. So 1 centimeter is to 250 meters. 4.5 centimeters is to what meters? Let's see. So 250 times 4.5 is equal to what? 1,125 meters. So that's the horizontal change. Now, we have to draw a right triangle. Let's say this is the right triangle. Vertical change is 600 meters. This one. Horizontal is 1,125 meters. What we're looking for is the hypotenuse and this angle. So, TOA tangent theta is equal to opposite side over adjacent side. Angle of theta is equal to the arctangent of 600 over 1,125. We get 28.07 meters. I'm sorry, degrees. Please, you've already seen how I made accidental mistakes. Try not to. Of course, the mistakes are inevitable, but try to avoid them. The value for angles are supposed to be in degrees, not meters. Only degrees or radians. But in the context of this lesson, our answer should be in degrees. Everything should be in degrees, not radians. For the hypotenuse, we write something like this. So the calculator, it's 600 raised to 2 plus 1125 raised to 2. We get 1,275 meters. That's the answer that's the hypotenuse. Yeah. Right, let's move on to the last question. Number 85, the height of a rainbow. While visiting the Lapahoho Memorial on the island of Hawaii, Bruce and Karma see a spectacularly vivid rainbow arching over the bay. Bruce speculates that the rainbow is 500 feet away. So, say this might be the adjacent, this is the hypotenuse. This is the height. So the angle of elevation is 42 degrees. Approximate height of the rainbow, this is what we're looking for. And rainbow is 500 feet away. This might be the 500 feet. Okay. I'm sorry. We need to find the approximate height of the rainbow. That's awkward. Anyways, we use TOA. Tangent 42 degrees is equal to the opposite divided by the adjacent, which is 500 feet. Opposite side is equal to 500 tangent 42 degrees. 500 tangent 42 degrees is 450.2 feet. This is the height of the rainbow in this specific problem, in this specific situation. So that's it. We finished all the way from number 78 all the way to 85. The previous video covered 77 all the way to number 71. So yeah, I think the series is finished. Thank you for watching. I hope this video helps.